You check the time. You glance at your watch, your phone, the clock on the wall. You see the numbers. You know what time it is, and you think you understand what that means. But here's what Richard Feynman would tell you. You don't. You really don't. Because time, the thing you think you're measuring, the thing you think is flowing past you right now, carrying you from past to future, it isn't real. Not in the way you think it is. Now, before you dismiss this as philosophical wordplay, as some kind of semantic trick, stop. Because this isn't philosophy, this is physics. And Feynman, one of the greatest physicists who ever lived, spent his entire career looking at what's actually there, not what we assume is there. And what he found, what the equations show, what experiments confirm over and over again, is that time is not what you experience it to be. You feel time passing. You feel it right now, one moment following another, moving forward, always forward, never backward. The past is gone. The future hasn't happened yet. And you're here in this knife-edge present, this now, being swept along whether you want to be or not. That's what time feels like. But feelings aren't facts. And the universe doesn't care what things feel like to you. Let me show you something strange. Take two events, any two events. You clap your hands in New York. A bell rings in Tokyo. Now, which happened first? You might think that's a simple question with a simple answer. Either the clap happened first, or the bell happened first, or they happened at exactly the same time. One of those three must be true, right? Wrong. According to relativity, according to the actual structure of space-time, the answer depends on who's asking. If you're sitting still, you might measure the clap happening first, but someone flying past you in a spaceship at high speed might measure the bell happening first, and someone else moving at a different speed in a different direction might measure them as simultaneous. And here's the crucial part. They're all right. There is no absolute answer. There is no universal clock ticking away somewhere declaring which event really truly happened first. You might think this is just about measurement, about the limitations of observers, about signals taking time to travel. It's not. This is about the structure of reality itself. The universe does not have a built-in ordering of events. There is no cosmic now. The idea that the entire universe shares a single present moment, that there's a moment that is now everywhere, is wrong. Demonstrably, experimentally, mathematically wrong. Feynman understood this in his bones. He didn't just know the equations. He felt what they meant. And what they meant is that time, as we experience it, as this universal river carrying everything forward together, doesn't exist. What exists is space-time, a four-dimensional structure where past, present, and future all coexist, where your birth and your death and every moment in between are all equally real, all equally there, just at different coordinates. Think about space for a moment. You understand that here and there are relative terms. Here for you is there for someone else. The universe doesn't have an absolute location that counts as here. Position is relative. What Einstein showed, what Feynman spent his career exploring, is that when is exactly the same. When for you is a different when for someone moving relative to you. Time is relative, just like space is relative. They're not separate things. They're part of one unified thing, space-time. Now you might be thinking, okay, fine. Simultaneity is relative, but surely time still flows. Surely we still move from past to future. Surely that direction is real. And here Feynman would ask you a simple question. Move? Move relative to what? When you say you're moving through space, you mean your position is changing relative to other positions. But when you say you're moving through time, what are you moving relative to? Time itself. That doesn't mean anything. That's circular. What's actually happening? What the physics actually describes is not you moving through time. It's you existing as a four-dimensional object. A space-time worm, some physicists call it. A structure that extends from your birth to your death. All of it existing in the four-dimensional structure of space-time. You don't move along this structure any more than a mountain moves along its own height. The structure just is. Your consciousness, your experience of now, is something else entirely. It's not about time moving. It's about which slice of your four-dimensional self you're aware of at any given coordinate. But all those slices exist. The you of yesterday exists in yesterday's region of space-time. The you of tomorrow exists in tomorrow's region of space-time. They're all there. They're all real. They're all equally present in the structure of the universe. Feynman had this wonderful way of cutting through confusion. He'd ask, what do we actually measure? What do the instruments actually show? And when you ask that about time, when you really look at what clocks measure, you find something interesting. Clocks don't measure time flowing. They measure intervals, the amount of space-time between events. Your clock doesn't tell you where you are in some universal river of time. It tells you how much has happened along your particular path through space-time. Think of it this way. A odometer in your car measures distance, but distance isn't a thing that flows. Distance is an interval between positions. Your odometer doesn't measure you flowing through distance. It measures how much space you traversed. A clock is exactly the same. It measures how much space-time you've traversed. It's an odometer for space-time intervals, that's all. And here's where it gets really strange. The amount your clock measures, the amount of space-time you traverse, depends on your path. Two people starting at the same event and ending at the same event, but taking different paths through space-time will measure different amounts. Their clocks will show different elapsed times. This is not a malfunction. This is not an illusion. This is actual space-time geometry. Time is not absolute. Duration is not absolute. The amount of time between events depends on the path you take through space-time. This is proven. This is tested. Atomic clocks flown on airplanes tick differently than atomic clocks left on the ground. GPS satellites have to account for this, or they'd be useless. The equations predict it. The experiments confirm it. Time is not a universal flow. It's a property of paths through space-time. Now, Feynman was also deeply interested in quantum mechanics, and quantum mechanics makes the picture even stranger. In quantum mechanics, particles don't have definite paths. They don't go from here to there following one specific route. They take all possible routes simultaneously. And this, Feynman showed, this isn't just an approximation or a calculation trick. This is how nature actually works. Feynman developed what's called the path integral formulation of quantum mechanics. The idea is simple to state, impossible to visualize. To calculate the probability of a particle getting from point A to point B, you add up contributions from every possible path, every possible path, the straight line, the curved paths, the paths that loop around, the paths that go backward in time and then forward again, all of them, and this works. This gives the right answers. This predicts what experiments actually show. But think about what it means. It means at the quantum level, there is no single path through space-time. There is no definite journey from past to future. There's a superposition of all possible journeys. The particle, if we can even call it that, doesn't travel through time. It exists as a probability distribution across all of space-time. You might object. You might say, but I see things happening. I see causes followed by effects. I see one moment clearly leading to the next. And Feynman would agree. You do see that, but what you see is an emergent pattern, a statistical regularity that appears when you look at large numbers of particles, when you average over quantum uncertainties, when you zoom out from the fundamental level. The laws of physics at the fundamental level, the equations that Feynman spent his life working with, they don't have a built-in direction of time. You can run them forward, you can run them backward. They work the same. The Schrödinger equation, the equation governing quantum mechanics, is time symmetric. Maxwell's equations for electromagnetism, time symmetric. The equations of general relativity, time symmetric. Feynman's own equations for quantum electrodynamics, time symmetric. So where does our experience of time come from? Where does the feeling of flowing from past to future come from? Not from the fundamental laws, from entropy, from statistics. From the fact that the universe started in a very low entropy state and has been evolving toward a higher entropy ever since. But entropy is not a fundamental feature of time. Entropy is a feature of configurations. It's about which arrangements of matter and energy are more probable than others. The arrow of time, the directionality we experience, emerges from entropy. But the existence of time itself, the idea that there is something called time that flows, that doesn't come from physics at all. That comes from consciousness, from memory, from the particular way our brains process information. Feynman once said, We have to find a new view of the world that's consistent with everything we know, in which time is not a flowing river, but something else. And that something else, according to our best physics, is a dimension, a coordinate, a way of specifying location in space-time, no more privileged or special than the three dimensions of space. You exist at certain coordinates in space-time. Right now you exist at a particular location in space and a particular location in time. But that location in time, that now, is only now for you. For someone moving relative to you, now includes different events. And all those events, past, present, and future, from your perspective, they all exist equally in space-time. This is called the block universe view. Space-time is a block, four-dimensional, fixed, unchanging. Your entire life, from birth to death, is a trajectory through this block. And the whole trajectory exists. Not was or will be. Exists. Present tense. All of it. Does this mean the future is predetermined? Here's where people get confused. They think if the future already exists in space-time, then it must be fixed, must be inevitable, must be determined. But that's mixing up two different things. The future exists in space-time, yes. But whether it's determined depends on the laws of physics, not on the structure of time. In classical physics, if you knew everything about the present, you could predict the future. In quantum physics, you can't. There's genuine randomness, outcomes that are not determined by prior conditions. But in both cases, whether deterministic or random, the events themselves exist in space-time. The difference is whether they're predictable, not whether they're real. Feynman had a wonderful way of putting this. He said we shouldn't ask what is real. We should ask, what can we predict? What can we measure? What do the equations tell us? And the equations tell us space-time is a four-dimensional structure. They tell us events are located in this structure. They don't tell us that some events are more real than others because they're in the past. They don't tell us the future hasn't happened yet. Those are not features of the physics. Those are features of our psychology. Your memory works in one direction. You remember configurations of lower entropy, and you exist in configurations of higher entropy. That's why you remember the past and not the future. Not because the past is fundamentally different, but because entropy has been increasing and your memory is a physical process subject to entropy. If you could reverse entropy, if you could make the entire universe run backward, you would remember what you currently call the future, and you would anticipate what you currently call the past. The direction would flip, but space-time itself would be the same structure. The only thing that would change is the direction of increasing entropy. So when Feynman says time isn't real, he doesn't mean nothing happens. He doesn't mean change is an illusion. He means the thing we call time, the flowing river, the universal now, the distinction between past and future. These are not fundamental features of reality. They're emergent features of our particular perspective within a four-dimensional space-time. Think of it like this. You watch a movie. The movie feels like it's happening, unfolding, moving forward. But the movie exists as a complete object. The film, digital or otherwise, contains the entire story. Beginning, middle, and end all exist simultaneously as parts of the film. When you watch it, you experience it sequentially, but that's about your experience, not about the film. Space-time is the film. Your life is a sequence of frames in that film, and your consciousness experiences those frames one at a time, creating the illusion of flow. But the frames are all there. They're all real. They all exist in the structure. Now you might find this disturbing. If the future already exists, if your death already exists in space-time, does anything matter? Can you change anything? Are you free? And here Feynman would remind you to be careful with language. Change means difference over time, but we're talking about time itself. You can't change time. You can't change your path through space-time because your path is all of your choices, all of your actions, all of you, extended through the time dimension. But within that path, within your experience, you make choices. You deliberate, you decide, and those choices are real. They're part of what determines your path. The fact that the path exists in space-time doesn't make the choices less real. It makes them part of the structure. Here's an analogy. A novel exists as a complete object. All the pages, all the words, all there simultaneously. But the characters in the novel still make choices. Those choices are part of what makes the story what it is. The fact that the story exists as a complete artifact doesn't make the choices unreal. It means the choices are part of the story. You are a story written in space-time, and the choices you make are part of what that story is. The fact that the story exists doesn't diminish the choices. It contextualizes them. Feynman was always suspicious of metaphysics. He wanted to stick to what we can measure, what we can test, what the equations actually say, and what they say is clear. Time is not a separate thing that flows. Time is a dimension of space-time. Events don't happen in time. Events are locations in space-time. The past isn't gone. The future isn't yet to come. They're directions in space-time, like left and right, up and down. Does this mean time travel is possible? In principle, yes. General relativity allows solutions where you can travel along paths that loop back to earlier time coordinates. Whether such paths actually exist in our universe is an open question, but the fact that the equations allow them tells you something. It tells you time is not fundamentally different from space. If time were truly a flowing river, time travel would be nonsensical. You can't go back in a river. But if time is a dimension, then traveling to earlier coordinates is no more paradoxical than traveling to a different location in space. Difficult, maybe. Requiring exotic conditions, certainly, but not fundamentally impossible. Feynman himself was cautious about time travel. He knew the equations allowed it, but he also knew our equations might be incomplete. We don't have a complete theory of quantum gravity. We don't know what happens at the smallest scales, the deepest levels. Maybe there's something we're missing that rules out time travel. Maybe not, but the possibility itself shows how different time is from our intuitions. So what are we left with? What does it mean to say time isn't real? It means the thing you think of as time, the universal flow, the absolute distinction between past and future, the river carrying you forward, that's not in the physics. That's not in the structure of the universe. That's a feature of your experience, a consequence of entropy, of memory, of the way your brain processes information. The actual universe, according to our best theories, is a four-dimensional space-time, static in the sense that all events exist, dynamic in the sense that events relate to each other through laws and causes, but not flowing, not becoming, not moving from potential to actual, just existing, all of it, all at once. Though all at once isn't quite the right phrase because that suggests a time, and we're talking about time itself. Feynman would probably laugh at the difficulty of language here. We don't have good words for this. Our words evolved to describe our experience, and our experience is of flowing time. But the universe doesn't speak our language. The universe just is what it is, and what it is stranger and more beautiful than the categories our language gives us. You are not traveling through time. You are a four-dimensional structure extended through space-time. Your consciousness is perceiving slices of that structure sequentially, creating the experience of now. But all the slices are there. All the moments of your life exist in space-time. You at 5 years old, you right now, you at 90, if you get there. All equally real, all equally there, just at different coordinates. This doesn't make life meaningless. If anything, it makes every moment eternal, not in the sense of lasting forever, but in the sense of being a permanent part of the space-time structure. Your joy, your pain, your choices, your experiences, they're not washed away by time. They're coordinates in the manifold. They're part of the shape of reality. Feynman lived like someone who understood this. He was intensely present, playful, curious, alive, not because he believed in the flowing river of time, but because he understood that existence itself, the mere fact of being, is extraordinary. You exist, not just now. You exist as a thread in the tapestry of space-time, and that's enough. That's everything. Time isn't real, not the way you think it is, but you are real. The universe is real, the structure is real, and your particular path through that structure, with all its twists and turns. Its moments of wonder and confusion, that's real too. The clock keeps ticking, but it's not measuring time flowing. It's measuring your journey through space-time, and that journey, right now, includes you hearing these words, thinking these thoughts, maybe questioning everything you assumed. Feynman would smile at that. Questions are where physics begins.